Welcome, ladies and gentlemen. I'm Terry Shoemaker with the Pacific Northwest National Laboratory, and I'd like to welcome you to today's webcast, Municipal Solid State Street Lighting Consortium Retrofit Financial Analysis Tool. Today's webinar is brought to you by the U.S. Department of Energy Solid State Lighting Program. We're very happy today to have as our speakers Edward Smalley of Seattle City Light and Doug Elliott of the Pacific Northwest National Laboratory. Edward Smalley is the director of the Municipal Solid State Street Lighting Consortium and has more than 20 years' experience in the design, construction, and operation of public outdoor lighting systems. For the past 11 years, he has worked at Seattle City Light, where he has been the street lighting engineering manager responsible for that city's LED street light conversion program. Edward is also the vice chair of the IES Street and Area Lighting Committee. Doug Elliott is a senior research economist for the Pacific Northwest National Laboratory. Since joining the lab in 1991, he has participated in a variety of projects focused mainly in the areas of energy policy, resource efficiency, cost-benefit, and regulatory analysis, plus software development. He received a BA in economics from Whitman College and an MA in economics from the University of Virginia. We will go ahead and begin.
Good morning, everybody, and welcome to the U.S. Department of Energy's Municipal Solid State Street Lighting Consortium's Retrofit Financial Analysis Tool webcast, and thank you for joining us. We hope that you will find this program useful and that it will help you get the most out of your use of the tool as you plan to prepare budgets for your LED programs. Many of you are members of the consortium, a volunteer group of street and area lighting owners from professionals across the U.S., comprised of utilities, municipalities, and other users. As you look at the map that is now on the page, you'll see that it represents about 340 such organizations across the U.S. If you are not a member at this time, you might want to consider joining. Benefits include first-hand access to tools like the one we'll discuss today. As has been noted, this original Excel-based spreadsheet was developed by the Clinton Climate Initiative to assist some of the largest cities count the costs of undertaking large-scale efficiency conversion projects. Working with CCI, we've modified the program so that large and small-sized cities and utilities can get similar results with minimal support. Some of you will be joining us in Los Angeles on April 19 and 20 for the Consortium's workshop, where we will discuss other topics like today's discussion in depth and in detail. We've teamed up with the City of Los Angeles to provide details on many of the user aspects of an LED program of any size. If you haven't planned to already, please join us. You can find details on our website or contact us directly. In the meantime, for the next 30 minutes, please give your attention to Doug Elliott as he walks us through the financial tool and points out details that may help you get the best use from it. Doug?
Thanks, Ed. Okay, I'm going to start out by talking a little bit about what the tool is and what it isn't. We've had a few questions that make us think there's a little bit of confusion as to the capabilities of the tool. First off, as to what it is, it's an analytical tool that we designed to evaluate both the costs and the benefits of conversions or retrofits from existing street lighting to LED street lighting. In actuality, it can be used to analyze any street lighting technology. Our primary focus to date has been on LED street lighting, and continued development will also focus on LED street lighting. Now, what it won't do for you is provide design assistance. It's not going to help you figure out what the appropriate fixture is for a given location or a given application. And it's also not a database of lighting technologies, costs, and performance characteristics. Now, design and cost and performance data, those are all very important items, and they essentially serve as inputs to the tool we've developed. But they're external to the tool, and the tool won't provide that information for you. So once the input data has been incorporated, what can this tool provide you as output. It provides the common financial metrics. Net present value is probably the most important one that's typically associated with life cycle cost analysis. It also provides internal rate of return and simple payback. And it also provides quite an array of detailed annual cash flow data from energy and energy cost savings, maintenance savings, as well as greenhouse gas reductions. Now, as Edward mentioned, this tool was developed as a collaborative effort with CCI and the consortium. Okay, so I'm going to start off by providing sort of a verbal and visual orientation to the tool. There's some of the sheets in the tool are fairly large, and it can be potentially intimidating or confusing initially when you look at it. You know, where does everything go? So hopefully this will shed some light on that. There are 4 primary sheets you're likely to interact with on the tool. There are actually a couple more included in the tool. There's an introduction page and a definitions page, which is essentially a glossary. But as far as inputs and results, it's all focused on the input page, the maintenance page, the results summary, and the finance page. Now, the maintenance page and the finance page are actually optional pages. They aren't necessary to get basic results. As you can see on this diagram here, there are actually 4 other sheets. There are 4 calculations worksheets that are essential to producing the results. But we've, in the release that we've currently distributed, we've hidden those sheets in the file. We aren't trying to hide anything keep anything from anybody or keep any information from anybody. It was mainly just an effort to simplify what could be perceived as a fairly complex tool. We just wanted to make the tool a little bit easier to navigate for people. Okay, now as for the input page. The input page is the primary, as you might expect given the name, the primary place where you're going to input data related to the project and individual fixtures. There are 4 sections to the input page. There's a global or project level input section that the data entered there affect all analyzed fixtures. And examples of such data points include electricity rate, greenhouse gas emissions factor, overhead costs, and labor and vehicle rates. Down below that, I'm actually going to switch over to the next slide here to provide you sort of a visual orientation of that. I just described the section labeled 1. Now, section 2 is technology-specific inputs or fixture-level inputs or fixture-specific inputs where data for each existing and new fixture are entered. So basically all fixtures that potentially will be analyzed by the tool need to be entered here, whether they be existing fixtures or potential new fixtures. And data entered in this section include lamp watts, fixture costs, maintenance cost, disposal cost, rebates per fixture. Then down below that in section 3 is where a user specifies which fixtures are going to be removed and which fixtures are going to go in place of the removed fixtures and how many fixtures will be installed. Now, this is a retrofit-only tool. We assume one-for-one retrofits. The tool doesn't deal with pole cost or pole spacing issues, and so the user can enter how many fixtures will be removed, and the tool automatically sets fixtures installed to be equal to that number. It's a one-for-one replacement. Now, up in section 4 there is a user editable area. I called it a user notes and scratch pad. That's simply a place where users can enter notes or use Excel's formulas to perform calculations necessary to derive inputs for other cells. That's all that is there. Okay, now on to the maintenance page, which as I mentioned before is optional but may be useful to many users. One can enter maintenance costs on the input page, but if and only if those costs are known on a $1 per unit per month basis for each fixture. If those aren't known, then it's necessary to visit the maintenance page. What the maintenance page does is it provides the ability to obtain a very detailed estimate of maintenance cost at the fixture level. So the maintenance costs are very specific to each fixture involved in the analysis. And it captures all costs associated with maintenance, labor, vehicle, and any equipment costs that may be involved. There are 3 sections to the maintenance page. I'm actually going to talk about number 2 first. The scheduled maintenance page handles lamp replacements, controls replacements, fixture replacements, as well as any scheduled cleaning. And the 3rd section there, we've labeled it emergency maintenance. It might be better labeled unplanned maintenance. That is largely similar to the scheduled maintenance section, with the exception of lacking cleaning. We assume that no unplanned cleaning goes on. Now, Section 1 is a section we added to provide some additional flexibility in the tool, such that it might handle some alternative or different purchasing or installation or maintenance scenarios. In that section, there are user overrides for labor, vehicle, and fixture costs. By default, the tool is going to use on the maintenance page the labor, vehicle, and fixture costs that were entered on the input page. If that's somehow not appropriate, there are drop-down lists that allow one to manually enter those costs on the maintenance page, such that there are maintenance-specific costs for those measures. Okay, now on to the outputs. The results summary page provides a variety of outputs once you've completed entering the input data. It provides a number of summary statistics, as I mentioned previously, net present value, internal rate of return, and simple payback. It also provides savings values for energy use, energy costs, and greenhouse gases associated with full implementation of the project. Now, many projects may not be implemented in 1 year. They might take 2 or more years to implement. And so the savings values reported on this page are associated with full implementation of the project. The results summary also shows quite an array of cash flow data, from capital expenditures to before and after O&M and energy costs, components of the capital expenditures such as labor, vehicle, overhead costs. And then there are also 3 charts provided at the bottom of the page. And here's what if you zoomed out on the results summary page, this is what it would look like. The section labeled 1 is where the summary statistics are found, and the section labeled 2 is the cash flow section, and then down in section 3 you can see the charts. Okay, now on to the finance page, which is another optional page. The results summary page, the financial metrics reported there, essentially assume that cash is on hand or budgets have been allocated to fund that project. Now, these projects aren't cheap by any means. That very well may not be realistic. And so the finance page, if necessary, allows one to examine debt instruments that may be used. And it's a fairly flexible page in that it allows up to 8 loans to be examined, and the loans can vary in length, interest rates, start years, and amounts. And then once one has determined what loans might work for the project, if you scroll down on the finance page, you'll find some summary statistics that compare the net present values and internal rates of return associated with the project, both with and without the debt service costs. So section 1, labeled on this slide with all the peach-colored input cells there, that's where the allocations of debt and equity can be examined by the user. Then section 2 is where the summary statistics, the comparisons of with and without debt, NPVs, and internal rate of returns are reported. Then section 3 down below, and as the arrow indicates, it actually extends quite a ways further down on that worksheet. That provides detailed cash flow data associated with up to the 8 loans. Okay, now I want to step through a couple of examples now that we have a little bit better idea, hopefully, of how the tool is organized. In this first example here, we're going to assume that the city owns 41,000 streetlights and it potentially wants to retrofit those with LEDs. And the city is going to purchase the replacement fixtures at a per unit cost. And these fixtures are going to be installed using the city's own labor and vehicle resources at an hourly rate. And one final detail is that this particular city employs a maintenance program that includes planned group relamping rather than spot relamping upon failure of lamps. Now I'm going to highlight a few key variables here. They aren't really important values in and of themselves, but in the second scenario I'm going to tweak these variables, so I wanted to mention the initial values for them. I'm going to assume an installation vehicle rate of $150 an hour, an installation labor rate of $400 an hour, and a per fixture installation time of 16 minutes. And if these costs potentially seem high to you, keep in mind that this isn't a per person labor rate, this is a per crew labor rate. And I also want to emphasize that the data that I'm showing you here, some of the data is real, some of it I've just made up to fit my example. The goal here is to illustrate the capabilities and the flexibility of the tool, not to provide an appropriate data set. Okay, so here we've zoomed in on the project level or global input section on the input page. And as I mentioned before, you'll see things like electricity rate, installation vehicle rate, there's a nominal discount rate, emissions factor, overhead costs. And in the red oval, you'll see that I've highlighted the installation vehicle rate of $150 an hour I mentioned, and the installation labor rate of $400 an hour. Okay, now I'm moving down to the fixture level or fixture-specific input section of the input page. You can see that we've entered 2 HPS fixtures there. Those are the existing fixtures, and 2 LED fixtures as potential replacements for those fixtures. Now remember, in this section, it needs to include all existing fixtures and any potential new fixtures that might be used to replace the existing fixtures. You can see to the right here, data entry required here includes lamp watts, system watts, and annual operating hours. Now I'm essentially going to scroll to the right in Excel here when I click to the next slide. So we're still in the same input section, just to the right in Excel, and I've highlighted there the install time, and I've filled in 16 minutes per unit, as I mentioned in the assumptions for this city's program. Now further to the right there, you'll see in the second red oval that there's a maintenance cost section there. Now where it says user entered in those various cells, it's actually a drop-down list, and you can specify there either user entered or maintenance page. And in this particular situation, I've chosen user entered, and I've entered $6 per unit per month for the HPS fixtures and $1 per unit per month for the LEDs. But in reality, I'm not quite certain about those costs, and so scrolling to hitting the next page, I've decided to change the entry in that drop-down from user entered to maintenance page for each of the fixtures, and that will require us to go to the optional maintenance page to determine our maintenance cost. Okay, one final input section on the input page. This is a section in which we specify which fixtures we're going to remove and which fixtures are going to replace the existing fixtures, and also how many fixtures are going to be removed. You can see we're removing just under 40,000 of the 100-watt HPS units and a little over 1,000 of the 150-watt units. And again, this tool only provides analysis of one-for-one retrofits, so the number of fixtures installed is set equal to the number of fixtures removed. Okay, now on to the maintenance page. As I mentioned in the assumptions for this scenario here, the city's using internal labor and vehicle resources for the installation, and we're also going to assume they're going to use those same resources, same crews for their maintenance program. So in this section of the maintenance page, this is where the user may specify either user entered or input page for vehicle rates, labor rates, and fixture costs. And I'm comfortable with going ahead and using the values for labor and vehicle and fixture costs that I specified on the input page, so I'm going to leave those set at input page. Okay, so this is essentially scroll to the right a little bit here on the maintenance page, and this is the scheduled maintenance section. I'm not going to go into too much detail about these various columns here. There are a number of comments embedded in the Excel file that help explain some potentially confusing items. A couple of things I did want to mention here, though. For example, up here where the laser pointer is pointing, lamp repair labor time and lamp repair labor cost next to it. In reality, those are a bit of a mislabel. I should have actually, well, those columns actually capture both labor and vehicle costs. So I just wanted to point that out so people aren't concerned that we're somehow forgetting or eliminating vehicle costs from our maintenance cost derivation. The other thing I wanted to mention was that in setting up this scenario, we assumed that this city performs scheduled group relamping rather than waiting until lamp failure. Well, up here in the lamp rated life, where the laser pointer is pointing to, in that case, in the case of group relamping, scheduled relamping, instead of entering the actual rated life in that cell, you'd want to enter the number of hours until the scheduled relamping would occur. And it would be a similar situation over here for the controls rated life. Again, you'd enter the hours until the scheduled replacement rather than hours until failure. The emergency maintenance section is largely parallel to the scheduled maintenance. And again, this is just unplanned maintenance in this section, while the scheduled maintenance section contains planned maintenance. And as I mentioned before, the only real difference in structure in the unplanned maintenance section here is that it lacks cleaning, because I think it's safe to assume that cleaning doesn't happen on an unplanned basis. Okay, now that we've entered the inputs on the input page and the maintenance page, we can move on to the results page to see what kind of bang for the buck this project is going to provide us. As you can see, I've highlighted here that the project is estimated to provide just under $21 million net present value and a simple payback of 6 years. And that's for a 15-year analysis period. In the peach-colored analysis period cell, that can be set to any integer from 1 to 15. So if you had a shorter time horizon or otherwise wanted to examine, say, what the net present value was after 8 years or 5 years, you could change that cell, and that would recalculate all of the financial metrics in this section here that are currently labeled 15-year. It would calculate them for whatever year you designate in the analysis period drop-down. Now in the next section below that here, that provides full implementation savings, energy cost savings, and greenhouse gas reductions. So in this particular project's case, it has a 4-year implementation period. So this new annual baseline kilowatt-hour use and energy costs that I'm highlighting right here with the laser pointer is associated with after all 4 years of installation have occurred. Then down at the bottom here, you can see this just provides first-year average capital expenditures per unit installed, and then also the subcomponents of those capital expenditures: labor cost, vehicle cost, overhead, etc. Okay, moving on to charts. The results summary also provides 3 charts. Here are two example charts, and for this particular project, you can see on the energy impacts chart that the installation of the LEDs resulted in energy savings of just over 50%. The new baseline annual kilowatt-hour use is just under 50% of the baseline. Now that's pretty impressive number, but if you look down in the cash flow here, the purple bars or bar components, that's the maintenance savings, while the light blue or teal bars above those are the energy savings. So in this particular example, the maintenance savings of the LED fixtures dominated the energy savings. They were both substantial, but the maintenance really provided the large share of the positive cash flows. Now on the far left of that cash flow chart, you can see 4 dark blue bars that are large negative numbers. Those represent the capital expenditures that occurred over the 4-year installation period. Okay, now onto the finance page. So this is not a cheap project. We may not have the budget allocated for it, so we need to examine debt options. Now up here where I'm highlighting with the laser pointer, you can see that total funding needed for this project is $19 million. And we're spreading it out over 4 years, and so each year we need roughly just under between $4.5 and $5 million for each year to implement the project. Now in the equity section, you can see that fixture rebates that have been received are entered as equity, and so that reduces the amount of the funding needed, and so now there's a total debt financing need of $15.6 million roughly. Now in the red oval there, I've entered four loans that would meet our needs here, and I've started one in year 1, another one in year 2. Essentially, I've created a loan for each year of the installation period, but it's entirely up to the user. The tool's happy to have different interest rates, different terms, different amounts, different start years. It's pretty flexible on that front. Okay, so as I mentioned previously, the results summary is showing net present values and internal rates of return associated, not taking into account any cost of servicing debt. And so on the finance page, once we've entered our desired debt instruments, you can scroll down and there's a financial stats summary section that provides NPVs and internal rates of return both with and without the debt service included, so you can see the impacts. In this case, our original net present value of just under $21 million has declined to $18.2 million once we took into account the cost of servicing the debt necessary to undertake the project. Okay, now on to scenario 2. Scenario 2 is going to be largely the same as scenario 1 with one exception. The city's decided to examine a different method of installing the fixtures. Rather than using its own resources, it's going to it's received a bid from a third party to install the fixtures at a fixed per unit cost of $119.17 per fixture. So you might ask, wait a second here. The tool has vehicle rate input and installation labor rate input. How am I going to fit a fixed per unit cost into the tool? It doesn't really seem to accept that. Well, it actually can with not too much problem here. If we learn from the contractor that the crew can install 6 fixtures per hour, we can then multiply the roughly $119 cost by 6, and that yields an effective labor rate of $715 an hour. Now in reality, that's not just a labor rate, that's a combined vehicle and labor rate. But what we're really after here is the total cost. We could enter this in vehicles under the vehicle rate or under the labor rate. It wouldn't really matter. It would still impact the bottom line exactly the same way. So in this particular example, I'm going to set the installation vehicle rate to 0 and the installation labor rate to $715 an hour. And the per fixture installation time associated with this third-party crew is 10 minutes per fixture, which is a fair bit faster than the 16 minutes per fixture in the first scenario we examined. So we've got here higher combined labor and vehicle rates, but reduced installation time. And again, as I mentioned in the first scenario, the data I'm using here are just per example only, just to illustrate the capabilities and flexibility that the tool provides. Okay, so revisiting the input page here, in the red oval there you can see that I've deleted the original vehicle rate of $150 an hour and left it blank or 0, and I've changed the installation labor rate to $715. Now moving down to the fixture level or technology specific section, I've changed the install time from 16 minutes to 10 minutes, but one thing catches my eye here. I see that my maintenance costs seem to have increased. Originally, the maintenance costs for the HPS fixtures, if I recall correctly, were somewhere between $5 and $6. Now they're over $6 per unit per month. So we need to revisit the maintenance page to see what might be causing a problem there. Okay, so now I'm on the maintenance page here. This is the section that allows user overrides of vehicle, labor, and fixture costs that had been entered on the input page. And if you'll recall in the first example, in this section, I specified input page in the drop-down list, indicating that the maintenance section should use the same vehicle and labor rates as we did for original installation. But now we've entered this $715 cost for labor, and that's fine for our installation. But in this case, the city is going to continue to use its own crews for maintenance, and so we need to override this and change the drop-downs up here in the top red oval to user entered and re-enter the original values of $115 an hour for vehicles and $400 an hour for labor. And that will now lower, as you can see in the smaller oval, the maintenance costs are now recalculated down to the $5.39 they originally were for HPS and 77 cents for the LEDs. Okay, so now we've changed the input for scenario 2. Let's take a look at the results, see how that impacts the bottom line. As you can see in this, the red oval I'm highlighting right now, it's a laser pointer. The NPV for a 15-year analysis period has increased from 21 million roughly in the original case to just under 22 million now, and the simple payback has fallen from 6 years to 5.7 years. And all we've done here is change capital expenditures. The capital expenditures in the second scenario on a per fixture basis and on a total basis were somewhat lower. And here's the results associated with scenario 1. I'll just switch back and forth. Hopefully it'll refresh quickly enough. You can see that the capital expenditures are slightly higher under the scenario 1, using scenario 1 data. Okay, now to look at charts associated with scenario 2. Given that we've reduced the capital expenditures a little bit with scenario 2, you'd expect that the dark blue bars on the left of the chart there that show the negative cash flows, which were the outflows for paying for the installation, you'd expect those to be slightly smaller in magnitude than under scenario 1, which had larger capital expenditures. And sure enough, when you look at a chart for scenario 1, the bars are slightly more negative. Okay, so that concludes my overview of the tool. I wanted to provide you some links and additional information and resources available to help you with the tool. The first link here provides you with the MSSLC homepage. And at the second link, if you haven't visited already, that's where you can download the tool. And there's also a couple of other files there that can be really helpful. There's what we call a tips document. It's essentially a frequently asked questions document. And that'll be a living document that we'll continue to add to as we receive more questions and provide more answers. And there's also an explanatory video of Emma Berndt of CCI demoing the tool several months ago. And if those documents and resources don't answer all of your questions, please feel free to email us at msslc@seattle.gov with further questions. And I also wanted to mention that we're certainly interested in comments and suggestions for the tool. We do intend to continue development of the tool. One feature that we would like to add is the ability to handle control systems. That probably won't happen for several months, but it is on our radar. Any future additions to the tool will generally need to have broad appeal to a wide user base and also be focused primarily on LEDs, since that's our focus. Well, that concludes the presentation portion of the webinar, and I think we're going to move on now to questions and answers.
Thank you, Edward and Doug. We have received several questions during your presentation. I would like to turn the Q&A moderation over to Bruce Kinsey. Bruce is the Municipal Solid State Street Lighting Consortium Project Manager at Pacific Northwest National Lab. Go ahead, Bruce.
Thank you, Terry. As Terry mentioned, we've had a number of questions come in. We'll try to get through as many of these as we can in the remaining time. And we may, these will be posted afterwards, and we will try to answer some of the others that we feel are particularly relevant and maybe didn't have time to get to here. We'll post those in the coming weeks. First question, this is for Doug. Is this analysis tool available to the general public, like lighting contractors, or only available to consortium members?
It's actually available to the general public. Anyone can go to the link that I just provided and download the file. There's no membership requirement.
Okay. Actually, most of these are for Doug, and I will, Doug, just assume these are for you, and then I'll point out when one has come in for Edward.
Okay.
Is there a password to unprotect the Excel file for data entry?
We're in an effort to avoid potential problems with editing of formulas that, well, basically we've locked it down such that we know what the formulas are. If we allowed broad editing of the tool, we could no longer guarantee the results.
This is just for data entry. The question specifically pertains to just for putting in data.
Oh, well, the data entry cells are all unlocked, so that they're fully available for user editing.
Is there an opportunity to evaluate bi-level lighting and or occupancy-based lighting?
I might defer to Edward on that one.
Well, I would think that we're really looking at what are the different, someone had earlier, I saw one of the questions that asked about ballast, and so really talking about additional components that may require maintenance, and so if those are grouped in, then some of those things can be compared, but you really need to keep track of the apples to apples comparisons, because you're really, if your old system doesn't have those features, is it truly a comparison, or is there value added with these additional features? So I would say that the tool is pretty flexible if you really track the different components that you're trying to have the tool do some calculations on, if that made any sense.
Okay, let me add to that a little bit. As Doug mentioned, we are planning to add some controls capability, some capability to evaluate controls down the road. And so right now, for example, adaptive lighting and dimming and other things like that, those are not included in the tool at the moment, but we do plan to add those going forward. Okay, next question. Here's one for Edward. What other kinds of tools are available from the consortium?
So one of the tools that we released back in November, actually we had a webcast in November, and we released on the 15th of October, was the model specification for LED luminaires. that was developed by the consortium. We also enlisted the help of the manufacturers, but basically that tool allows an end user to really compare and evaluate luminaires for roadway and some area applications, but it really has been very useful. We've used that tool in many different areas to put out RFPs and RFIs to request information on additional fixtures. So that tool is designed to be modified by the end user, and so that, along with some of the other things that we're working on a national survey to see, actually an inventory rather than a survey, to really see what different types of benchmarks are out there as far as number of lights, types, and qualities or technologies used. So tools like that, and then a lot of peer-to-peer involvement to find out, for instance, the workshop in LA, really get to some hands-on experience with other cities and municipalities and utilities that are working with these technologies to find out how they are getting results and the best results they are getting from these different experiences. So that, plus a number of other modifications, for instance, on the model fixture tool, we're looking at doing additional tools for area lighting and maybe parking lot or garage lighting as far as specifications for those areas.
Okay. Here's a question, and actually I can answer this one. Is there a version of the software for the Mac, or is this only Windows-based? At the present time, the software is only Windows-based. We don't have any current plans to produce a Mac version.
Oh, actually, Bruce, I want to jump in there. The tool should work. I haven't tested this, but if the Mac user is using Office for Mac 2011, I believe the tool should be fully compatible with Macs in that case. At the least, there will be some formatting problems if an older version of Office for Mac is used. But on the Windows front, if Office 2007 or 2010 are used, and on Mac, if Office 2011 are used, I think the tool will work fine in all those circumstances.
Yeah, and conversely, on the iPad, the Keynote doesn't have the functionality to process that level of data as well. The Keynote program on iPad.
Okay, here's a good question, and I don't think we've actually thought of this one, but there's probably a way, so I'll toss this one out to either of you. Is there a provision for early termination costs from the utility that currently owns the luminaire in bulb? And I assume that means if you are having them pull down their lights and replace them with LEDs, and you're being charged an early termination cost.
That's a good question, Doug. Had you put any thought into that?
As to where we would enter that?
Possibly, yes.
I believe that could be handled via the disposal cost column. I believe that any early termination fee like that could essentially be, that value could be entered in the disposal cost.
And then possibly track that note on the input page in that user inputs area, just to make sure we know what's in that area.
Sure.
Because I definitely recommend that a person, as they start to aggregate multiple values in a field, that they really track what's in those fields, so the next guy using this will understand what they've done. So I would almost call that a workaround for now.
Yeah, I was just going to mention that we've included another file up on the website that has some tips and things and workarounds and things like this, recognizing that we, particularly in the first version of this tool, we haven't necessarily addressed all possible permutations, all possible situations. In some cases, there are ways to achieve workarounds where you can basically get the numbers into the analysis, but maybe not with something that's, in this case, specifically called early termination, but maybe, as Doug said, this could be entered as a disposal cost or something. So there's a file up on the website that has some other ideas like that, suggestions and tips and so on.
Good point.
Okay, for Doug, do savings results take into account electric rate increases?
Yes, there is a section on the input page where a user can enter an assumption for annual change in electricity cost. And if you need help in developing an escalation rate for that, the input page also provides a link that to an energy escalation rate calculator that's based on EIA's annual energy outlook data as packaged by NIST. So in short, the answer is yes, it does take into account changes in electricity cost, assuming the user has entered an assumption for that escalation.
Okay. This is one that I will take. When will the presentation be posted online? Can it please be posted quickly so that we can share it with colleagues? Please give us the URL where it can be downloaded. The URL will be the same as the other tools that you can see that are currently up on the screen right now. We will try to get it up there as soon as we can. It'll probably take a week or two. Hopefully that's sufficient. We will try to get it posted as quickly as possible. Here's another one for Doug. How is a rebate calculated? Is that is a rebate based on state guidelines?
I think that actually might be more appropriate for Edward, because I think he probably has more direct experience with rebates.
Yeah, I was just looking at there. I mean, there's two ways that rebates are calculated. Sometimes they're per fixture. And Doug, is this based on kilowatt hour? I had thought it was kilowatt hour. And I'm just trying to get to that page. But basically, I think the end user needs to understand what their rebate is based on. And the program is not looking at any particular state or regulations or guideline or utility for that matter, because these items are going to differ from utility to utility. Even in California, there are 3 different large utilities offering rebates on this, but in differing ways. And so maybe we'll go into the next question. What I'll do is open up another page here to see if I can look at that. And Doug, is that readily available here on these screens?
The rebate value entry?
Yeah.
I don't know that that's shown. It's probably shown on one of the slides that covers the input page, probably on the same slide where I changed install time. But
yeah.
The rebate value...
I'll go to that offline here and see if I can get that answer within the next minute or so.
Okay.
Okay, Doug, please explain the net present value meaning for a set of lights or costs associated with them.
Well, the net present value, what that does is, given the discount rate you've entered, and in my example I used a 5% nominal discount rate, that's taking the entire stream of costs and, well, okay, let me back up a little bit, I'm sorry. It's comparing the life cycle cost of a base case situation with the life cycle cost of the potential new situation. So in the examples I provided today, we were comparing the life cycle cost of HPS fixtures versus the life cycle cost of LEDs. And by life cycle cost, that's taking into account, that's the discounting the future stream of costs to present value to establish in today's dollars life cycle cost for the HPS fixtures, and subtracting from that the life cycle costs associated with the new fixtures, and the difference between those two life cycle costs is the net present value. I hope that was getting at the intent of the question.
Okay. In the input page for fixtures, how does the spreadsheet differentiate existing versus retrofit, and is there room for, say, 15 different existing with 15 different retrofits?
There is room for 15 different existent. Well, let me back to answer the first part of the question. In that section, there's no differentiating between existing and retrofit fixtures. That's specified down in the next section below that, where the user specifies which fixtures are going to be removed and which fixtures will be installed. That's how existing and retrofit are defined down in that section. But in the section where all the fixture data is entered, they're all just mixed together, and that doesn't cause any problem. And there is room for, let's see here, yeah, there should be no problem to enter 15 of each kind in that data entry section.
And Bruce, if I could just jump back in on the previous question. There are two ways to handle a rebate. So a lot of times utilities will handle it on kilowatt hours saved. In this program, on the input page in cell Q58, rebate value, it's asking for a dollar value per unit, and then what one would do if the utility offers it per unit, they would enter that dollar value there, but likely they would have to calculate the kilowatt hours saved per unit over the incumbent technology and then multiply that out. Say, for instance, if it's 22 cents per kilowatt hour times X number of kilowatt hours saved, then that value would go there. And then on the finance page, there at section C13, you'll start to see where you'll see it calculated out as total number of units multiplied by the rebate, and then it'll show you there what that total savings would be. And then that is subtracted from the project costs, I think, let's see in the results summary. I believe there is a results summary on the results summary page. There's a rebate value as well, so, and I don't see that offhand.
Yeah, there is. There's in column J. There shows the rebate cash flows.
Okay. There we have it.
Doug, can you please review where the energy price is entered, and if an inflator escalator adjustment to the price per kilowatt hour can be entered as well?
Okay, that's similar to the previous question. On the input page, I could just call out the cell. In cell D16 or D15 is where the electricity rate is entered on a dollar per kilowatt hour basis. Then right below that, there's an annual change in electricity cost percentage that can be entered there, and both those values are the user needs to drive those values. But as I mentioned before, there's a link to an energy escalation rate calculator that's region specific that can help come up with the escalation rate if better information isn't available.
Okay, here's one I can answer. Can you share a sample spreadsheet with dummy numbers in it? There is actually, I believe it's downloaded at the same time. I believe both those two come together as a zip file. Correct me if I'm wrong, Doug.
That is correct.
Yeah, so there's a blank version and a version with sample numbers in it when you download it. Why did you choose a 15-year period? That would be about 65,000 hours of burn time. Is there any residual value for time periods shorter than LED rated life?
Let's see here. We chose the analysis period in that example, 15 years, because we assumed that the life of the LEDs would be 15 years. I guess I don't see a reason to use a analysis period shorter than the anticipated life of the fixtures, because you're not going to capture all the benefits of the fixtures that they provide.
Okay.
On the residual values, I'd have to put some further thought into how we're currently handling that. I don't recall off the top of my head.
And I just might add that while the analysis period just shows how far out do you want to look at these values, it's really relatively inconsequential when you're starting to look at your financial analysis in the end, because you're really concerned with the payback period. And so an end user is going to look at that. And in this example, I believe it was 7-point-something years, which one might use for their financial and grant purposes.
Okay, we have time for one more question. This one's for Doug. Can this tool be adapted for other types of energy efficiency investments, or does DOE have other tools for these?
Well, as far as lighting, we haven't tried to use it for other lighting types, but we think it's probably quite adaptable to at least to things such as parking lots and possibly parking garages. Some of the labeling used in the tool might not be perfect for those circumstances, but essentially the same data would be required. As for, I mean, this tool is fairly specific to lighting, so I think it's most applicable to other lighting technologies. As for performing a life cycle cost analysis or cost-benefit analysis for other technologies, other non-lighting technologies, I think other tools that DOE provides would probably be a better fit. BLCC is one tool that's available on the FEMP website that provides fairly generic life cycle costing capabilities, and it's a fairly powerful and relatively simple to use tool. That's the one that comes to mind.
Hey, thanks very much. Terry?
Thank you, everyone, for participating in today's webcast. It was brought to you by the U.S. Department of Energy,